Trigonometry, a branch of mathematics we all thought was the endgame of math when we were younger. All it is defining the relationship between a triangle's angle and its side length. Now, it doesn't sound that bad, does it? In this video, we'll be going over the primary trig functions and SOH CAH TOA. And by the end, you'll be able to solve right angle triangles using sine, cosine, and tangent functions. What is sine, cosine, and tangent? Sine, cosine, and tangent are the three primary trigonometric functions. Because they're a function, they require an input value in order to produce an output. For example, sine theta on itself doesn't have any value, but sine 30 does, which is 1 over 2. Trigonometric functions are only able to take angle measures as their input. For example, the 60 you see in tangent 60 is an angle measure, in this case 60 degrees. Now, there is another widely used unit for angle measurements apart from degrees known as radian. Simply put, radian is a different unit for angles, like how kilometers per hour and miles per hour are different units for speed. In this video, I'll not be going over radian as it is generally covered in higher level trigonometry. It may sound funny, but SOH CAH TOA is required for a stable foundation in trigonometry. As I mentioned earlier, trigonometry is about establishing the relationship between a triangle's angle and its side length, such as a ratio. Sine, cosine, and tangent are exactly that, ratios of the sides of a right angle triangle. When given a right triangle, we know that the longest side is known as the hypotenuse. But what about the other two sides? If we have a reference angle, like so, we can define the side facing it as the opposite side, because as the name states, it is opposite to the angle. For the other side, we can define it as the adjacent side because it is next to the reference angle. Please note that the opposite and adjacent sides differ depending on the reference angle. The S in SO represents the sine of the reference angle, in this case theta. The OH represents opposite over hypotenuse, and when combined with SO, it simply means sine theta is equal to opposite over hypotenuse. Knowing that, we can easily determine the other two. Cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. Now, what does this look like in practice? Let's go over a few examples. Given this triangle, let's try to find the values for sine theta, cosine theta, and tangent theta. Take a moment and pause this video to try it yourself. Using SOH CAH TOA, we know that sine theta is opposite over hypotenuse, which in this case, the opposite side of theta is 3 and the hypotenuse is 3 root 5. Thus, sine theta for this triangle is 3 over 3 root 5, which simplifies to 1 over root 5 or root 5 over 5 if we were to rationalize. For cosine theta, we know that it is adjacent over hypotenuse, therefore 6 over 3 root 5, which simplifies to 2 over root 5 or 2 root 5 over 5 if you were to rationalize. For tangent, we know that it is equal to opposite over adjacent, thus 3 over 6, which nicely simplifies to 1 over 2. For this second triangle, let's try to find the value of x. Pause the video and try for yourself first. First, for a problem like this, you must determine which trig function to use. Using the known angle, we notice that sine or cosine would not work here, as it would either introduce a new variable or not include the variable you're finding at all. Thus, we use tangent here. Using SOH CAH TOA, we know that tangent 51.3 degrees is x over 4. Isolating for x, we get 4 tangent 51.3 degrees is equal to x, or approximately 5. Now, what if we switch things around a little and make the angle the unknown variable? Just like the previous example, we must determine which trig function to use. In this case, sine and tangent would not work as it would both introduce a new variable. And cosine would work because it involves both of the known sides. Using SOH CAH TOA, cosine theta here is equal to 5 over root 34. Now we must isolate for theta here, somehow. We can do that by using the inverse cosine function. Applying inverse cosine to both sides of the equation, the inverse cosine and cosine cancel out, to leave theta, isolating for theta. Using a calculator to compute the right side, we get that theta is approximately 31 degrees. I know what you're wondering. What are inverse trig functions, you may ask? This concept shouldn't be too confusing for those who already have background knowledge in functions, but for the ones who don't, inverse trig functions, as the name states, are simply just the opposite of the original trig function. This is shown by the fact that, for example, when you take the inverse sine of x, the inverse sine and the normal sine cancel to just leave x. It also works the other way around. For example, when you take the tangent of the inverse tangent of x, the tangent and the inverse tangent cancel to give you x. Also, please note that the power of -1 you see on inverse functions is not an exponent, but rather just a notation. For example, inverse of cosine of x is not equal to cosine of x to the power of -1. If you want more practice or harder questions regarding this topic, consider checking out my second channel focused on practice questions. Link to the video is in the description below. And other than that, that'll be the end of this video, and I hope to see you in the next one.